Okay, now we need to find the value of x, right here. Okay, here also let's mark what are the information we can mark. Now they tell now this now AODC is a straight line and O is the center. That means AD is the diameter, right? From this diameter, that means A and D subtended angle at circumference. This must be 90. Normally we call semicircle angle. This must be 90, right? You can write it here 90. This will be 90, right? That's the idea. This is the edges of the diameter A and D, right? AD is the diameter. From AD, subtended angle at circumference here must be 90. Okay, I can mark that. And not only that, here very important one, but here you can use alternate segment theorem. Alternate segment theorem, because they tell now this BC is the tangent. BC is the tangent. At the tangent point, you can see this BD chord. This chord, right? BD chord here. This chord subtended angle at circumference is 20, right? BD subtended angle at circumference is 20. That means this will be equal to what the angle between chord and the tangent, right? That means this one will be equal to here 20, right? This will be 20. We can do here 20, right? This 20 here will be 20. Then you need to find x now. You can write like this way. But if you consider ABC triangle, this angle plus this should be 180. So you can write what the 20 plus this complete angle. This one mean 90 plus 20 now. This big one, this part 90, this part 20. So you can write 90 plus 20. You can write 90 plus 20 mean what the it should be 110. Okay, I will write together this one 110 plus x should be 180, right? Now here x equal 180. When you add this together, 130, if I bring to here, it will be minus 130. Then here will be x equal 180 minus 130 mean 50 degrees. So that's the answer for x.